Awesome. So we're also going to launch a poll just to get another better idea of who we're talking to. Looks like we've got a decent amount of brewery staff. Awesome. We've got some home brewers and a couple just beer geeks as well. Awesome. Well, we appreciate everybody joining us today. It's an awesome topic, and it's something that we've kind of presented before a couple years ago in person. I think it was for the California Craft Brewers Association conference when it was in San Diego. But something that I think is always pretty fun to talk about. My name is Erik Fowler, the education manager here at White Labs. If you've been on these before, you've seen me talk on different aspects of fermentation, but more importantly, I'd like to introduce Curtis Davenport. I appreciate having you here today, and it's pretty exciting that although we couldn't have done this in person, we've still been able to manage to keep this partnership up.
Yeah, hello.
You want to tell us a little bit about yourself and your position and who Admiral Maltings is?
Sure. Yeah, so I'm Curtis, and yeah, thank you, Erik, for having me. As Erik mentioned, I'm the head maltster and co-founder of Admiral Maltings in Alameda, California. So we are a small, well, in the malting world, a relatively small craft malt producer. So we'll tell you a little bit more about our process later on. But as you can see in my photo there, I'm standing in a field of barley. And before I was making malt at Admiral, I was growing organic fruits and vegetables, and small grains in Santa Barbara County in California, and kind of got into malting from the agricultural perspective, kind of for two reasons. One being, and I think Erik and I will speak a little bit to this later on, but kind of seeing a disconnect between the craft brewers who are operating, at the sort of regional or even neighborhood scale, and kind of considered like a vibrant part of that local economy, but not having a really huge connection to local agriculture, which is where I was working. So kind of wanted to bridge that divide, and also really wanted to help develop a market for small grains in California. It's a crop that can be grown with very few inputs, especially very few water inputs. So you can grow grain in most years without any irrigation, or just with small amounts of supplemental irrigation. And so the idea of connecting, brewers to farmers who could grow this sustainable crop, that's what got me excited about malting and why I am now a maltster.
So to that point, I mean, that connection or almost disconnect is interesting, and how that really drives what you are all doing. I know terroir is something that's debated within malt, but could you almost say that terroir does play a role? Because I mean, you're talking about the development of this crop due to where it's being grown and the varieties being grown. Like, is that not a sense of terroir, even if it's not directly impacting flavor in a traditional sense?
Yeah, no, that's definitely I wouldn't say a contentious issue right now. I'd say it's a lively discussion amongst maltsters and brewers and malt scientists. But yeah, absolutely, there's an element of terroir to malt. It's it's an agricultural, beer is an agricultural product, and I think any agricultural product, any food is going to have is going to bear the the characteristics of the place that it was grown and how it was processed. And in malting in particular, I think some of those attributes are trying to be teased out, and there's a lot of different relationships between those attributes. People talk about the genetic impact on flavor, the environmental impact on flavor, and then the process impact, and those all have kind of synergistic relationships too, where the process might bring out some of the characteristics that are, that were inherent to the crop year or the place that was grown or the soil that it was grown in. So I could talk for a long time about that. I don't know if this is necessarily the presentation for that. But absolutely, there is the flavor is developed at kind of all of those different stages. And I think in particular in this presentation, we'll kind of focus on the malting process and how that impacts the malting process and how that impacts the brewing and fermentation processes, where that flavor is really developed.
Yeah, definitely. And that's, something that I hit on home a lot is it's something because it's not spoken about enough in beer is how does it affect flavor and how do you tell the story through that? Like, what does it mean to the consumer? Because to me, this is really cool, but if we can't communicate why it's special to the person drinking it, then something's lost. And you pick up a bottle of wine, and as an industry, they've done a really good job for a long time promoting the regionality of those products and why it's special and why it's important. And just as you're saying, I mean, there's so much manipulation that goes on to grapes from the winemaking side that could still completely change it. But when we're talking about ingredients in beer, it tends to not be viewed with the same respect, which is often a bummer. And everybody on this call obviously is interested in it, but on the production side and the ingredient handling side, there's a lot of interest and respect for it. But when it comes to consumers, they expect more consistency. Whereas wine, the consumer is a little bit more okay with vintage variation from year to year. But it's such a delicate balance.
Yeah, there's definitely that notion that malt is, this kind of blank, and this is, I think, changing. I'm not sure how many brewers who are on this webcast now would feel this way, but I think there's somewhat of an unfortunate reputation of malt for being, a homogeneous blank slate that, flavor is built on top of, and really just like a source for sugar. And of course it is a source for sugar to make alcohol. But yeah, there's a lot of variety and character between malts, and any maltster, really regardless of scale, I think would tell you that malt is a dynamic and dynamic product that's just full of variety.
So as a whole, I mean, when we're looking at the broad spectrum of available malts, most of the flavorful malts tend to be European malts, right? Is that in partially due, and I'm talking mostly by volume and availability, is that partially due to the process over there and the varieties they're using, or is it just because a lot of the big breweries for so long domestically have cornered that market and they've dictated what needs to be grown here?
Yeah, I mean, I think that's it. The North American malt and barley supply chain, you're right, was really followed beer production trends in the U.S. Of course it did. You wouldn't make a maltster, wouldn't make malt for if that's not for a product that was demanding something differently. And for a long time the demand was for 6-row malt that was used in adjunct beers, where the malt character and the malt flavor was intentionally being minimized in those beers. And it was, the number of brewers were declining and becoming more centralized. And so then the malt production became more centralized, and kind of became, it did become a more homogeneous product where, there wasn't this wide variety of different styles of malt being produced in North America. And so I think American craft brewers who are looking for something other than 6-row adjunct malt, had had to look to Europe to, smaller kind of craft producers who were making the styles of malt that they needed to make the styles of beer they wanted to make. That's definitely changed a lot over the past decade or so in North America. There's now the North American Craft Maltsters Guild, which represents, well, Brent, who's the president, could correct me, who's on this webcast, could correct me with the exact number, but it's dozens of craft maltsters who are now producing malt at a scale and producing styles of malt that are more relevant to craft brewers.
Yeah, the camaraderie is pretty impressive, and there's a lot that resonates with what breweries do with each other, right? The way all the maltsters kind of work together has been pretty awesome. Before we go to the next slide, what am I looking at on this right here? It looks like your warehouse.
Yeah, that's floor malting. So what you're mostly seeing is green malt. That's malt that's been steeped in those shiny tanks with the orange bases. Those are our steep tanks. And so the barley or wheat or rye or oats would start in those tanks and soak in water for about 2 days, and then be spread out onto the malt floor where it will germinate for 4 to 6 days. And that's really I think we'll get into this in a future slide, but that's really the heart of malting is the transformations that happen on the malt floor. So I'll just dive into that. So the stages of malting are steeping, germination, and kilning. Before I talk about those stages, I'll just talk about the purpose of malting is really, the malting process and the mashing process in brewing are kind of part of the same general process to transform an unfermentable starch found in barley or other cereal grains into fermentable sugars that yeast can consume and produce alcohol from. And so that process, really involves what, maltsters, we talk about modification, and that's basically transforming the whole inside of the barley kernel to remove all of the structures that are protecting the starches. So you can see in this diagram, there's cell walls made of large complex starch cellulose molecules, beta glucans, arabinoxylenes, penoxans. Those are kind of forming the cell wall, and then there's a whole protein matrix, and all of those structures are protecting the starches, and then the starches themselves are wound up into really complex chains, and those eventually need to be broken down into sugars. So really the purpose of malting is to get rid of these cell walls that are protecting the starches, and also to develop and synthesize the enzymes that will be later used in mashing to convert the starches into sugars. And so that starts, as I mentioned, in steeping. So the whole grain gets soaked in water, and that allows water to penetrate through the whole endosperm, which allows all of these modification processes to happen. They need to happen in water. That's how the enzymes move through the endosperm. So steeping kind of sets the table, and then during germination, all of the different beta glucan and protein enzymes are doing their work and breaking down. I'll see how many times I can say beta glucans in one slide. I'll start breaking down the beta glucans, and then right at the point where all of those structures are degraded, but before the seed really starts growing a whole barley plant, then we want to put it in the kiln to halt that process. And so the kiln is where the green malt gets dried out. So just unless you had a brewer here right on site who could immediately make beer out of the green malt, we need to be able to preserve it so that it can make its way and travel to a brewery and be easy to handle. So drying is a practical thing we need to do, but it's also where a lot of flavor is developed. We're kind of cooking and lightly toasting the green malt, and that's what brings out a lot of the bready, nutty, biscuity, all the flavors that we associate with malt are really kind of produced in the kiln.
And we had a question come through. What's the general temperature when you are steeping? And I'm sure there's like a water to grist ratio. And does that change by variety?
Yeah, the water to grist ratio would not be anything as important as it would in mashing, other than we just need to cover all of the, we don't want to just want to cover the cover the grain and give it a little bit of headspace to move around as we aerate it. But the temperature is really key. We steep, for just average would be, just under 60 degrees Fahrenheit. That's kind of warm enough to get the grain active and living, but cool enough that it's keeping that, going in a really controlled process, a really controlled manner. And that's just kind of the sweet spot that maltsters have discovered over the years.
So do you actually have to chill your water certain times of year to hit that, or is there a little bit
Yeah.
of flexibility?
Yeah. Right now we're pretty much we hardly have to chill it. But yeah, we, in the summer months when our water's coming in warmer, we chill that down to hit the right, by the time you put the warm grain in and the cold water, then we want to end up at right around 60.
Cool. So, now we can kind of talk about converting some of those sugars and extracting some of those sugars. Like you set up the grain so that it's stable for the brewer, has a lot of precursors and different aspects of flavor that can be extracted from it. But now it's up to the brewer to manipulate that, right? And there's a lot of opportunity to do that depending on your mash schedule, your temperature, and then more importantly, adding other ingredients and how they might interact with it as well too, right? Depending on what yeast strain that you choose or work with, so talking about the three main sugars in malt being maltose, obviously the primary, maltotriose, and then glucose in smaller quantities. Certain strains can vary in the conversion of some of those sugars, and especially maltotriose, which gives you that attenuation range, right? And then some of those dextrins, which we can talk about too. But yeast take those sugars, and we primarily look at CO2 and ethanol, but from a craft brewer standpoint, there's over 500 flavor and aroma compounds that are made by or contributed or affected by yeast metabolism. So there's a huge amount of impact that yeast has even on the malt profile and the perception of that. And we've got a brewery here in site in San Diego, in which we did a collaboration with you all a couple of years ago, which we can get to. But we do the same. We've got a 20 barrel brew house and 16 5-barrel fermenters, and we'll split batch everything, and usually in two, and we'll do two different yeast strains. And it's always pretty mind-boggling how much different yeast strains can change the perception of other ingredients, whether it's a hoppy beer and the strain produces more esters and this one's cleaner, or as we're talking here, a malty beer, like how much of that residual sugar is left, or is the strain really dominant or producing a lot of flavor that might mask that, or is it really clean? Obviously, like a lot of English strains tend to be great strains to promote some of those aspects of malt and some of that balance, but also showcasing some fruitiness depending on the strain, whereas Belgian strains are extremely expressive and dominate any other ingredients. So, from a yeast perspective, I encourage looking at the totality of all the ingredients and how they're going to interact, because if you're looking to produce a beer where you want to showcase this heirloom malt that's really special and tells a cool story, you might want to select a yeast strain that allows that to be showcased and not dominate that and promote the right aspects. So it's not always 1 and 1 equals 2, right? It's looking at the totality of all the ingredients and how they might play a role.
Yeah, and Eric and I were talking about that before, that that kind of synergy between malt and yeast. And we were both saying, we wish we could do just like endless research on finding exactly which yeast strains work really well with which particular malt types, or just kind of getting a better understanding of that, like all those particular relationships. And I think that is something that really comes down to us kind of learning from our customers, and hearing from brewers, their experience. Like in this particular beer, we use this yeast strain with this malt, and we got flavors that we wouldn't have got from using that malt with a different yeast strain, or that yeast strain with a different malt. So I think there's it's just it's really exciting to start to learn more about that, and pull that apart. And unfortunately, we don't have the answers that that one X plus Y necessarily equals Z, but those relationships are certainly there.
Yeah, there's a lot of variables, and I think when we get to the slide on nutrition, it might open up that conversation a little bit more to what are some of the things we could look at to maybe help narrow that scope. But it is hard. I mean, most breweries, even if we're talking about a 20,000 barrel a year brewery, it can still be fairly small in the grand scheme of things. And replicating consistency is obviously a big focus, but it can be hard to replicate that in a different facility sometimes under different conditions. So it's all, it's all trial and error, and it's all about what profile the specific brewery is looking for. So here we're kind of looking at different kilning profiles, and it looks like you have a couple different malts. So when I'm reading this, am I looking at the specific variety of malt, or am I looking at the same variety kilned differently and maybe just labeled differently on your end? Could you explain that and explain why you'd have different kilning profiles for these, and what that even means?
Sure. Yeah. And just a little background, that this chart was this was from the presentation that Erik referred to previously, where we that presentation was brewing some beers at White Labs. Maybe you can talk a little bit more with the particular details, but the idea was to kind of have a different carbohydrate profile, and then brew a beer with it, and see what the resulting sensory and chemical profile kind of that beer was. And we were looking a lot at like how the malting process and the kilning process in particular changes the composition of the malt as to what is being delivered to the brewer. And so this chart, it does show, you're right, it shows 3 styles of malt. I think they were actually made with 2 different. The Pacific Victor was made with 1 barley variety, and then the Feldblum and Admiral Pils were made with a different barley variety. Then they're each kilned differently. And the chart here is showing the temperature in the kiln over time. So the y-axis there is temperature in Fahrenheit, and then the x-axis would be the roughly 24-hour period of kilning. And really the purpose of this was to show kind of how these 3 different styles really differ from each other. And so, at the beginning of kilning, you can see that the Pacific Victor, which is a Vienna style malt, and Feldblum both undergo this kind of stewing period at the beginning. And then I'll speak more to the details of that. But as we go on, there was also a Pacific Victor had a recirculation, where recirculating the moist exhaust air, and then at the end, the curing differences are just showing that subtle differences in temperature can create lots of different aromas.
So looking at the stewing, it isn't labeled, but I assume this is temperature.
Yeah, Fahrenheit. Yep.
Okay. And when you're looking at these peaks and drops, is that just your equipment kicking on and off, or is that intentional?
Yeah, this could have been, smoothed out, because really what that is that's showing we vent the kiln to uh, get rid of some of the humid, like, steamy air. It's not actually steam, but just the air vapor, the water vapor. We open up the dampers in the kiln to get rid of that, and so the temperature drops, but the temperature of the grain is staying about the same. And what this, stewing at the beginning of kilning, what that does is we're changing the composition of the starches and sugars that are in inside the malt. So we're holding this at pretty low, what would be like a really low mashing temperature. You can see we're just over 100 for the Feldblum, and then getting into like 130 for the Pacific Victor. And we're essentially at that period, doing a mash inside of the malt kernel. So the green malt that's been on the floor, it's still full of moisture. The endosperm is soft and hydrated, and so by holding it at kind of mash temperatures, we're doing the same thing a brewer would. The enzymes that are in there are going to start consuming, start breaking down some of the starches and especially proteins, creating simpler sugars out of those, and simpler, smaller proteins and amino acids. And so the kind of transformation that happens during stewing, that sets the table for the higher temperatures that are applied during curing. So if we, you can see, if we kiln something at 190 degrees, that's gonna, the aromas that are produced during curing are going to be different based on the composition of that green malt. So if that was green malt that hadn't gone through the stewing period, it just went through a normal drying and then was cured at 190 degrees, you would end up with one range of aromas. But if you had done this stewing in the beginning of kilning and kind of transformed the composition of the malt at that point, you'll end up with a whole different flavor and aroma profile. So really the purpose of this slide was just to show that how our process, how we're kind of continuing to modify and craft the malt in the kiln, and that's going to deliver different a different carbohydrate profile, a different protein profile. It's a different starting point for the brewer to make their beer from.
Awesome. And I got a question that came in that's semi-related, but also to clarify, this process specifically, you guys only work with producing base malts, right? You're not doing any specialty malts, and those temperatures would be a lot different.
Yeah, the Pacific Victor would be kind of, you could describe that as a base malt, or it's getting into the specialty malt range. It's something you could, use at 100% in a beer for like a rich sort of, Vienna lager. But yeah, in our kiln, we produce a whole range of malts. We do actually make some, dark caramel malts that are close to 100 Lovibond. But yeah, the Admiral Pils, that's a Pilsner style. Feldblum, we don't really give that a traditional style name, but it's somewhere between a Pilsner style malt and a pale malt, and then the Pacific Victor would be a Vienna style.
Cool. And even though these are more unique malts to themselves, you kind of just have to associate it with styles of malt that are a little more well known. I assume is why you kind of compare that way.
Yeah, that's always a tough balance to strike, because we're not in Vienna, so it feels kind of funny to call it a Vienna malt, but that's what brewers do have the kind of lexicon of what they expect from a Vienna malt, and so our malt needs to fall roughly within that. But we'd also like to think that our Pacific Victor is different from every other maltster's Vienna style malt, and every maltster's Vienna malt, or even Pilsner malt, is going to be a unique thing. It's I think the lexicon is helpful, but we need to understand that, it's the same way that an IPA from one brewer is not an IPA from, another. So yeah, there's a lot of room for creativity and unique characteristics even within like a typical style.
Right on. The question that came in that I wanted to touch on was, when we're talking about base malt, you mentioned 6-row for some of the more industrialized malted barleys, but what are you specifically working with? In the context of the question, they've done 2-row barley for their beers because the research has shown that 6-row has higher diastatic power. The seed has more protein available, but currently the industry uses 2-row. So I guess why? That's probably the...
Yeah, that's right. I mean, we use mostly 2-row barley. All of these, that you're looking at, those 3 styles would have been made with 2-row barley. Yeah, the question, nailed it. 6-row has typically higher protein, higher enzymes, and so it became popular for styles of beer that were using a lot of adjuncts, and you needed the malt to have enough enzymes to convert not only itself but all of the other unmalted adjuncts. And so for craft brewers, that's really not what a craft brewer who's making typically an all malt or close to an all malt beer. You don't need the malt to carry so many enzymes and such high fan. We'll get into that also a little bit later, but the kind of malt attributes of 6-row, it has, it's very malty in the sense that it's got lots of enzymes and lots of fan, and you need that if your mash has a lot of unmalted adjuncts. Yeah, so this, go ahead, Erik.
Yeah, maybe looking at this, I feel like we could talk on this slide for a long time, but to push through it a little quick so we can get through some of the other content, could you talk on grain variety and looking at Copeland, and I assume that's UC Davis?
Yeah, UC Davis, Buddha 12. It's a variety bred at UC Davis. Yeah, so we won't go too deep into this, but I think the point was just to show, in those kiln profiles, what the results were. And so, we end up with higher color for Pacific Victor, and a really particular thing is we end up with a way higher soluble over total protein down there on the second bottom half of that chart. And that's because of that stewing in the beginning of kilning. A lot of the proteins were being digested with enzymes and going from large proteins into smaller soluble proteins. So this was kind of just to illustrate how the malting process, both in steeping, germination, and then in kilning, how that's influencing the composition of the malt that will eventually be mashed and fermented. And then the varietal differences here, they're not, I wouldn't say they're totally teased out in these numbers. There's the impact of variety here is kind of minimal. Mostly the difference in these numbers is coming from how it was malted. But in general, a variety like Copeland might have higher S/T even if it was malted as Admiral pills. Slightly higher, I guess that the alpha amylase there, you see that Copeland had a slightly higher alpha amylase. That's the kind of a varietal characteristic. But really, I think the point or the takeaway there is that from everything from the genetics of the barley to how it was grown, how it was malted, that's all what we would talk about. A kind of a term that's being used now is functional terroir. So the variety and how it was grown, how it was malted, is going to change how you need to brew with it, and as a result, what those flavors are going to be. So it's not just that when you harvest barley from a particular field, it tastes like strawberries because of that's like the flavor note from that field. It's that the way it needs to be malted, the way it needs to be brewed is how you're going to end up with with particular flavor.
And yeah,
That
you
makes
know,
sense.
yeah, it totally does, and it just shows that there's, you know, as I was alluding to before, there's the inherent characteristics of the product, the agricultural product you're working with, but it's also not only how the brewer manipulates it, but how the maltster manipulates it too. And a lot of that character that's unique to the malts that you guys produce are partially unique because you're the ones to actually malt them, right? If those if the same barley went to another malt house, it's likely going to turn into a different malt and taste
Totally.
very different and turn into a different beer.
Yep.
Um, from the yeast perspective, yeast need nutrients, right? And again, when we're looking at malt, we're primarily looking at carbohydrates. That's what's most often looked at and spoken about because that's what's responsible for producing, ethanol and the majority of byproducts. But where it's taken for granted is a lot of other aspects like some of the vitamins and minerals, but looking at FAN, right? That nitrogen source in the form of amino acids. And when we first started working together a couple of years ago, that's something we started to dive into and something that we are excited to continue to explore. But that amino acid profile, when you were looking at here, you're just looking at one overall number, but that number consists of many different amino acids and different variations in quantities depending on the malt and how you're handling it. And then you put yeast into the picture and the way that the yeast prefer the different amino acids and the groups and how they're actually metabolizing that nitrogen source varies a lot, and that really affects flavor a lot too. And so that's something that is a little less understood and spoken about because there's so many variables there. But it can be a really cool aspect of how malt and yeast work together because it's not necessarily producing X specific malty flavor, but it might be providing an amino acid that then turns to a beautiful ester or some aspect of yeast metabolism. So there's we've seen it more in brewers switching to say hard seltzer where it's always been a given that barley has all the nutrients. You haven't really had to think about it too much. But when brewers switch to producing another beverage that doesn't have that nutrition readily available, it's kind of an eye-opener. And I think it shows that brewers can take the nutrition that yeast provide for granted, right? I also have oxygen on here because it's obviously very important, but kind of neither here nor there in the context of what we're talking about. So yeah, as I mentioned, amino acids being a primary source of organic nitrogen from malt, used in the production of proteins, and then complexes for cell wall components, different enzymes in the form of FAN or amino acids. And then we're looking at, most strains requiring between 100 and 150 ppm FAN. But some of the numbers that you had listed were even above that, right? Did you want to speak on that at all?
Sure. Yeah. I mean, I would say we would love to see our numbers end up closer to what the yeast needs so that there's not excess FAN after fermentation. And that's really even I think I think the numbers are, it was like, 9% protein. So that the FAN, the amount of FAN in malt starts with just the amount of protein in the barley. So if you have high protein barley, you're going to end up with, there's really no way to not end up with a lot of FAN if you have to modify the malt enough to make it usable. So you're going to end up with lots of FAN. So starting with low protein barley is the first thing we can do to try not to deliver a lot of extra FAN. And the reason we don't want to deliver extra FAN is that when you have those amino acids hanging out in the beer after it's finished, those are just the starting points for off flavors to develop. I think it's more of an issue in packaged beer, but there's really, I think, not a lot of use for extra fan after the beer is finished. But besides the protein content, which you can see in the previous slides, we were working with really low protein. I think it was like 9.4 protein, and the other one was around 10%. So really nice, moderate protein content. But that's really the job of barley breeders, to develop varieties that aren't producing so much fan.
Yeah,
So
and where we might see types of brewing that might be insufficient of fan would be, different types of high gravity where maybe you're using a lot of adjuncts or a lot of simple sugars that, the yeast at those higher gravities need those additional nutrients, and then lack of them as well, could also show itself in sequential generations of yeast too, if you're looking at repitching a lot and the medium in which you're using it in is devoid of proper nutrition. You might see a decline in yeast viability or performance from that too, and that could be indicative of inadequate nitrogen sources.
yeah, and again, just kind of getting at the fan, as you mentioned, that's just the total free amino nitrogen in the wort, and what specific amino acids that is, that's not something that's currently measured. I'm sure some brewers are, with very sophisticated labs, are measuring that for themselves, but that's not something that we have measured on our malt analysis. But it'd be really cool. So I guess this is a pitch to anyone out there who could study that. We would love to know, exactly which amino acids are, what the composition of that fan is, because that's going to be a lot more meaningful for a brewer to know, okay, yes, we need enough, of X amino acid, and we really don't want a lot of extra Y. So
yeah, and then
that's just kind
variation
of to
on
tease some, future interest, and just to mention that this isn't all totally understood right now.
Yeah, I saw a post on the Master Brewers Association forum come through this morning that was asking about how many breweries are looking at fan levels and at what points, and I assume pre and post fermentation and what they're doing with that information and how it's affected their process. So very relevant to our talk today. I thought it was the timing was kind of funny. I want to leave some time for Q&A. I think we have one or two more slides, but yeast nutrition, looking at flavor, I think we touched on everything on here except for maybe unfermentable starches and dextrins specifically. From a yeast perspective, from a flavor perspective, it's very important, right, for lending structure and body and balance to a beer. But from a yeast perspective, it's generally not something, those carbohydrates aren't generally usable from the yeast. There are some exceptions there if you're talking about more wild type yeasts. Brettanomyces or some of the more Belgian-esque strains have the ability to, over time, break down some of those dextrins. That process tends to take a lot longer than working with traditional brewer strains. So instead of a 5-day fermentation schedule, you could be talking about 30 days plus, depending on what type of strain. But instead of working with yeast to do that, because generally that's undesirable unless it's intentional, how can the brewer kind of manipulate that, or where does the maltster come into play with the different balance of these different types of carbohydrates?
Yeah, I mean, well, the brewer can definitely manipulate that in their mash and the times and temperatures. I think particularly temperatures, with just roughly, generally speaking, a higher temperature mash, leaving more dextrins in the mix, and a lower temperature mash, having a more thorough conversion. And the reason for that, being beta amylase being mostly responsible for chomping off the individual maltose molecules, and that is going to be denatured at the, the higher mash temperatures. And so if you get rid of your beta amylase, then you'll have a lot of dextrins left in there. But then from a malting perspective, the level of modification. So how well, going back to that you don't have to go back to it, but that one of the very first slides showing the cell walls, if some of those are left intact, then the enzymes in the mash aren't necessarily going to be able to access the starches as well. And so you might end up with some dextrins and larger starch molecules that have making their way into the wort.
That can be intentional sometimes too, right?
Oh
Use
yeah.
unmalted barley.
Yeah. Or less malted, a less modified malt. And then and then just the barley variety, how many enzymes it's delivering. So if you had a really high DP malt, then you're going to have more beta amylase, more alpha amylase, in there. You're just going to have a hotter, not hotter temperature wise, but a faster, more active, more enzymatic mash. And so some brewers don't want that. They actually want a lower DP, so they have a little more control. And a lot of the malt styles that have been kind of characteristic of North American malts would have had really high DP. And so a craft brewer trying to mash with those malts might have less control over their mash and end up with less dextrins than they want, because they mash and everything happens like that, and it's all fermentable sugar.
I feel like I touched on that a lot, but could you, we kind of spoke about looking at the right yeast strain based off of the attributes of different malts. How do you suggest a brewer looks at choosing the right malt, other than looking at a recipe and says this traditionally calls for Vienna, so when I'm going to Admiral, I'm going to ask them what their closest malt to Vienna is?
Yeah. Let's see. I won't go through all of these because I think we should leave some time for more Q&A. But I'd say a big thing is looking at the color to see it's going to match the color you want. That one's pretty simple. And then just talking with that, there's not really a great way to describe aroma. I mean, we give flavored notes and on the COA, but it's really about talking with the maltster and talking about, hey, what character is this malt going to deliver, compared to your other malts, or perhaps compared to another maltster's malts. And yeah, I mean, I'll just sum it up by, saying conversation, and, we try to put as much information on a certificate of analysis, but a lot of that really needs the context and conversation to pair with it. So.
Yeah, we struggle with that a lot too, because everybody will ask, what flavors does this yeast strain put off? And over, through a lot of anecdotal experience, like, we run every beer we do through the lab, and I can tell you, what quantity of certain esters are there, or different aldehydes, or different fusel compounds, but it's really just it's the experience of using the strains in multiple beer styles and trying them from different breweries to be able to say, this strain usually has, a pear note that I haven't seen in other strains. But when somebody's specifically asking, how's this going to taste in my beer, again, it comes back to, it depends, and there's so many variables, and it can give you some guidelines, but really the dialing that in and manipulating that on the brewer's end, I mean, that's some of the art of it, right? If we could tell you exactly that this yeast strain and this malt always produce this beer, everybody's product would taste the same. Yeah. But the fact we can start with the same raw ingredients and produce vastly different beers, I think is actually the creative reason that a lot of us are drawn to this industry and supporting this industry.
Totally.
So, just understanding the story behind every raw ingredient you're working with, and I am always a big advocate of passing that story along to the consumer. Most people that are spending the premium on craft beer want that connection, and they want to understand it. It might not be something more than a shelf talker, something written on a label. But so much of our products consumed over a bar, and people want that engagement and that connection. And I think it's awesome. The same reason that we have 3 facilities globally here, in Asheville, North Carolina, and then Copenhagen, is you can produce yeast at one location and ship. I mean, we can ship overnight to anywhere in the US and get yeast very quickly. But being able to plant roots and get to know those communities, and get to know those regional preferences and the brewers and the people using it, I think is just so crucial. And I know you all do a great job, and that's why I've enjoyed working with you so much and seeing you at trade shows and grabbing beers and all that. So I do want to thank you for taking time today. I think it's an awesome conversation. We could probably do another part of this, every couple months and still have plenty to talk about. But there are a lot of questions on here, so I'm going to skip around a little bit. So for your base malt production, does your company offer a malt profile in comparison with other grains? So,
yeah, I mean, I guess what the information we offer is the certificate of analysis. So that'll go through the typical malting quality parameters, and I guess you would need to compare that to other malts, but it's there is a pretty standard template for malt quality. Everyone's looking at color, extract, alpha amylase, diastatic power, soluble protein, on and on. So we do kind of use the same format for comparison. I'm not sure if that totally answers the question, but yeah.
I think it's great. Another question: what percentage of protein in malt may cause higher turbidity in beer? And what would the significant increase, for example, be from 9.8 to 10.1% or much more? Looking at NTU. So yeah, go for it.
Yeah, I mean, the range of protein content in general would be like between 9 and probably, well, for us, between 9 and 11.5. Malt in general, probably more like 9 to 13% or so. So that's kind of the total range. And in terms of which of those would cause haze, I mean, you could have a really under-modified, it'd really be the soluble over total ratio, or the larger proteins, I think, are what gonna cause the haze. And so it'd be probably more the composition of which proteins versus the total content of them, and that would be depend on how it was malted, the level of modification. So unfortunately, not like a single number you can point to and say that's going to create a haze and this one isn't. But I would look at a lot of the haze probably coming from really low S over T values. So where a smaller percentage of the protein is being converted into smaller soluble proteins.
Cool. This is kind of one that we were joking about when we were setting up this webcast. But is there anything we can do from malting or mashing stage to prevent hop creep in highly hopped beers? So, we were just joking around that anytime doing a supplier panel or anything like this, that you always ask the hop people about enzymes, because they usually don't want to talk about it, whereas yeast and malt love talking about it. And you might have a different answer, but I don't think there's any manipulation that can really be done on the malting or mashing side. I mean, I'm sure there are different carbohydrate profiles that might affect potential hop creep, but there's still so little known, even between lot and lot, of the enzymatic power of different hop varietals. Generally temperature for your dry hop, I think is one way of manipulating that, but that doesn't really have to do with the malt side of it. I don't know if you have a different stance on that.
Yeah, no, I don't know. It seems like, I mean, you would need to get rid of like of carbohydrates that will potentially be fermentable sugars later. But I don't think many brewers want to have a beer without any residual sweetness or mouthfeel. So there's, that seems like a tough thing to balance. You want a beer with body. You don't want a really thin beer, but if you have a beer with body, then that body is potentially fermentable later on when the hop enzymes get after it. So
yeah, and we saw
yeah.
brute IPAs kind of try to take off for a very short period of time, and I've actually had a couple decent examples over the last year that don't label it as brute IPAs, or they're using an addition of enzymes to help dry that beer out and create more fermentables for the yeast. But a lot of light beers, I think, are where that's kind of gaining too, but that's kind of here nor there and compared to hop creep. Last question though, how do you measure the parameters like on your so like,
Yeah,
are you doing all the testing in-house or externally for the parameters
yeah.
that you're supplying your
Most
customers?
Mostly externally with a malt lab. We work with the Hartwick College Center for Craft Food and Beverage. So a lot of big maltsters will all have their own malt labs, pretty sophisticated. They'll have chemists on site who are doing all of the wet chemistry analysis. But for the small maltsters, we all work with kind of all pool our malts and work with labs that are providing that as a service. Usually they're university-based labs. But then we'll measure friability and moisture content and kind of do sensory analysis in-house and like a color reference in-house. But all of anything that has like a official ASBC method attached to it is being done at a third-party lab.
And last but not least, where can anybody find more information on Admiral Maltings? I will provide, on the YouTube video description, some links and an email that gets sent out to everybody here. But for reference, where can they check you all out?
Yeah, the internet's a good place to start, just on our website. But then beyond that, just I think the best way is just get in touch with us over email. So yeah, Erik will drop that in there, but I'm just Curtis at admiralmaltings.com. And then for brewers who are, looking to brew with Admiral Malt, Ron at admiralmaltings.com would be the best person to contact.
Awesome.
Or,
thank you all.
Actually, the best way is to come by and to our pub and say hello. We're open for outdoor dining now, and hopefully, I don't have to talk about COVID right now, but I think we all know that hopefully, this later this summer or fall, we can all get a lot more actual FaceTime together. So that's something we miss.
Yeah, I still can't believe that I haven't made it up there. So
yeah,
hopefully on the list for the next 12 months at some point. But yeah, thank you for taking time today. It's an awesome conversation. I had a lot of fun. I wish we could have done it over a beer, but maybe soon enough. And I'll definitely keep working together and keep spreading the gospel of everything you're doing, because I personally feel really passionate about everything that you guys do, and your malt and the beers that it produces have always been outstanding. So
yeah, thank you. Thanks. Thanks for having me, and thank you everyone else for joining. It was a lot of fun.
Awesome. Thanks, Curtis. I'll talk to you soon.
All right. Bye.
Bye.